Welcome to the video about material flow analysis, also known as MFA. But before we will discuss MFA, we will first look back at LCA. By now, you are familiar with life cycle assessments, or LCAs. LCA is a fantastic tool for understanding the total environmental impact of specific products or processes. But let's be honest. In a complex healthcare setting, LCAs have challenges. If done rigorously, they are highly detailed, time-consuming and incredibly complex, often requiring trained specialists to conduct them. Frankly, it is just not feasible or wise to do this for every single item or procedure a hospital uses. Conversely, if they aren't detailed enough, they risk being used for greenwashing. Furthermore, large-scale LCAs often use spend-based data to estimate environmental impact, meaning they calculate carbon emissions based purely on how much money was spent, rather than the actual physical materials used. This is highly unreliable in healthcare, where the high price tags of specialized medical equipment and patented drugs rarely reflect their actual physical footprint, severely skewing the data. So, how do we look at the bigger picture? Enter material flow analysis, or MFA. While MFA is relatively new to healthcare, its origins lie in industrial ecology. Recently, it has become a powerful driver for healthcare sustainability. Why? Because a massive portion of a hospital's carbon emissions don't come from electricity or heating, the so-called Scope 1 and 2 emissions. It comes from Scope 3 emissions, specifically purchased goods. We usually know exactly how much electricity a hospital uses, but the materials that they consume, that's most often a black box. Doing an MFA opens up that box. It shows exactly what types of products are entering the hospital, how they are used, and how they leave. This reveals our hotspots and helps us prioritize our green initiatives effectively. So, what exactly is an MFA? In simple terms, it is a systematic assessment of the flows and stocks of materials within a defined system boundary. The core principle is the law of conservation of mass. What goes in must come out. To make this concrete, let's look at something completely unrelated to the healthcare sector: online dating. And before you ask, no, this is not my personal dating life. This graphic is called a Sankey diagram, the classic visual tool of MFA. Here, the system boundary is a person's dating life. On the left, we see the inputs, 13 matches from Tinder and 7 from Bumble. That's a total of 20 matches entering the system. The width of the bands represent the volume. But where do they go? Following the flows on the right, we see the outcomes. 7 ghosted, 6 didn't show interest, and 4 led to coffee dates. Notice the mass balance here. If you add up all the final outcomes on the right, the unmatched, the ghosted, the crazy, the rejections, and the one successful relationship, it perfectly equals to 20 matches that went in. What goes in must come out. In a hospital MFA, we do exactly this, but instead of tracking dating matches, we track medical supplies. So, how do we actually conduct an MFA in a hospital? Here is the high-level 4-step process. Number 1, defining your system. You need to establish your boundaries. Are you analyzing one ICU or the entire hospital, over a week or a year? And what specific clinical materials are you tracking? Number 2, identifying the variables. This is a qualitative stage where you essentially draw the map. You determine what materials you are tracking and where they physically move, tracing the path of specific material components as they flow between different hospital departments from entry to disposal. Number 3 is quantifying the data. This is the quantitative stage where you put actual numbers on the map. You figure out exactly how much material is flowing along those paths. And finally, you balance and you visualize. You verify your mass balance by ensuring that what entered the hospital equals what left as waste. And you transparently document these findings using a Sankey diagram to visually map the volume of those flowing materials. Now, let's zoom in on step 3 for a moment. Figuring out exactly how much material is flowing can be the hardest part of hospital MFA. We generally link our variables to real data using 2 main approaches. The first is the top-down or logistical approach. This relies on hospital purchasing records and procurement data. It is fantastic for understanding the broad inputs of what is entering the hospital, but it doesn't always tell you how it is actually used. The second is bottom-up, or a waste audit approach. This literally means putting on gloves and physically sorting and weighing clinical trash. It is dirty work, yes, but it's highly accurate for measuring the outputs at the bedside level. Let's look at our own recent MFA study of a 50-bed academic ICU to see this in action. By mapping the medication flows over a full year, we found a striking hotspot. Out of the 245,000 kilograms of annual medication inflow, only 2.3% was the active drug. The vast majority was the inactive carrier fluids and nearly 40,000 kilograms of packaging, generating 1.7 kilograms of waste per patient daily. MFA pinpointed our heaviest impacts, like the massive waste from the continuous renal replacement therapy bags, a specific waste stream that we have now successfully started recycling. You simply wouldn't see these physical inefficiencies so clearly with just an LCA. And before you rush out to do your own MFA, be aware of a few critical challenges. These are, for instance, the level of detail. How detailed should you be? Getting lost in the granular data of every single syringe and alcohol swab can paralyze your study. Second, system boundaries. What materials do you actually include? Do you count the food in the cafeteria or only clinical supplies? As we mentioned in step 1, defining this clearly is crucial. Then we move on to material identification. You often won't know exactly what type of material or product or its packaging is made of. To figure this out, you might have to contact the manufacturer, look for a material passport, or use specific scanners. Or sometimes just resort to feeling and experimenting with the material. Carbon translation. MFA measures mass, usually in kilograms or tons. If your ultimate goal is to find your carbon footprint, you will eventually have to map these weights to carbon conversion factors, which adds another layer of complexity. Despite these challenges, the benefits of using MFA in the healthcare sector are immense. Because MFA relies on visual tools like Sankey diagrams, it translates complex environmental data into an intuitive format that doctors, nurses, and hospital management can immediately understand. It takes the invisible, physical flows of hospital supplies and makes them tangible. Furthermore, it can be performed directly by healthcare workers themselves. It's often much faster to conduct than a full LCA and is far less dependent on proprietary information from manufacturers. This allows frontline clinical staff to easily spot actionable hotspots, like excessive packaging, providing a clear, evidence-based starting point for targeted waste reduction and circular economy initiatives across the hospital. We started this chapter talking about the black box of hospital materials. MFA is the tool that finally turns on the lights. By mapping these physical flows, we move from guessing about our impact to actually seeing it. And once we can exactly see what we are using and wasting, we can finally take control of our environmental footprint. Thank you for watching.